Hello, everyone. So thank you for coming first. I'm going to talk about Habitat and what is subtitled Application that Travels with the App. So first, who am I? So my name is Romain. I'm from France, as you can guess by my beautiful accent. I'm currently a tech lead at Nuxeo, which is a company working on a platform for content management. So we are hiring, so if you may want to discuss that with me, I'm available afterwards. Above all, I think I'm an Habitat core plans maintainer, so this is why I'm presenting Habitat today. So first, a little story and context. So what led me to Habitat? How did I encounter it? Oops, sorry. So I've been working for 5 years for my previous employers. Especially during 4 years, we were working splitting a monolith into microservices. So this is apparently the theme of the conference. We were, during that time, 2 developers, so me for the 4 years, and the other developer was changing every 1.5 years. And what we did, actually, when we split this monolith, we focused mainly on the application code, and not so much on the infrastructure, because we didn't have the hand on the infrastructure, so we could barely ask for new EC2 instances, and once they were provisioned, that was it. So we went for simple. Simple means that we had only 2 environments, so one for pre-production and one for production. And on each environment, we had like 8 services running. And the way we deployed them was using what I call container tarbals, because it's trendy, but because it actually contains everything that the application needs to be running. And we deployed these tarbals every end of the sprint, so every 2 weeks. Whoops, sorry. So we were satisfied with what we had. I mean, like, the software was good. We were content with that. But we needed more on the infrastructure part. So we wanted no more SSH. By that I mean that we wanted to consider the infrastructure as a commodity and don't have to actually connect with SSH on the instances to actually manage them. So I didn't talk about the logs and many other parts because they wanted for this talk, and I could have created like another, so I could have submitted another talk for that. So here we will first try to see about configuration management. So as I said, it was in the tarball, and we wanted to actually decouple it from the source code of our application and have it centralized elsewhere so that it would be easier to manage it. Continuous deployment too, so this was something we wanted from the start, but it takes a lot of time, I think, to have a team that can mature and be able to do that, except you start from scratch and put it in place at the beginning. And we wanted an infrastructure agnostic tooling so that excuse me, so that we could easily adapt to the infrastructure changes. So as we didn't have the hand on the infrastructure, we were dependent on them, and we still wanted to control how we do stuff. So this is where I came to know about Habitat. So Habitat is a project backed by Chef, so the company that created the configuration management tool. Sorry. It was announced like 2.5 years ago, and it's currently mainly revolving around, the community around it is mainly composed of early adopters, of which I'm part. And they are currently focusing on the 1.0 so that they can actually like communicate a lot more about it. So what does Habitat bring? For me, it's an innovative vision. So they coined the concept of application automation. For years now, we have heard about infrastructure automation, how we automate infrastructure so that we can actually put the applications in production faster. But they started to think about it the other way around. So on the left, you can see this is the traditional way of deploying applications. So first, you take care of the operating system. You use every provisioning tool you want for that. And then you make sure it's hardened, so you use a configuration management tool for that. And then you put the libraries you want to have, so for example, an OpenSSL, the JDK, stuff like that, and then finally your application. So this is kind of brittle or fragile, depending on where you stand. And it also means that the focus on this pyramid actually is at the bottom. And what delivers value to the customers is what's at the top. So Habitat reversed this by putting the application first. So You start from your application, you specify all the dependencies of your application inside Habitat, and when it's done, this package that is generated from your application will actually be runnable on any OS that supports the architecture you targeted. So Docker, for instance, for now is on the left, because you still start from something, and then you add your dependencies, the libraries, and then your application. And Habitat starts the other way around. So how does it do that? So first, it encapsulates and automates your application. You have to think of Habitat as really a habitat, so that's the term, of your application, meaning that it provides everything the application needs to work. So for that, you can create packages for your application. So this is why Habitat is a package management solution. You create a package in which everything will be specified for your application. And also, the Habitat comes with a supervisor that will actually manage the lifecycle and the configuration of your application, even the version if you need it to. So now we run into the different parts of Habitat. So how do you package your application? So first, you use something called the Studio. So the Studio is basically a chroot on Linux. It's a Docker image on macOS, I think, and Windows 2. It's a clean slate. This is the place in which your application will be able to run. So you have 0 dependencies inside, so just the minimal stuff to be able to have a shell and some core utilities. And once you get into this Studio, you can actually write a plan for packaging your application. So the first 3 are just metadata, so these are the coordinates of your package, the soon-to-be-built package. The dependencies are the runtime dependencies needed by your application. So for example, here it's the plan for the application I want to demo next, which is a Spring Boot application, so we need the JRE to be able to run our application. And we also can specify build dependencies. Since the build is happening inside the Studio, we need to specify the tools we need to actually build our application. So that's it for the variables. And we have some functions so this is shell actually, just bash, plain bash. And we have some several phases during the build, so we can override them or just use the default ones if you want. Default ones are mainly targeted to the C, C++ programs, because Habitat can actually package any kind of language or platforms. Platforms, I mean language platforms. So the do build will just actually build the application that's inside the package. So here we just launch the mvn clean verify command so that the jar will be generated. And then during the installation, we actually put all the files needed inside this pkg prefix path, which is actually the place on the disk where the package is stored. So everything inside this place will be actually inside the package. So once you have created your plan, you will build it. So this is just one command, of course. And then it will spend some time building. And then it will say, I love it when a plan.sh comes together, because the core team likes the A team. And then in the results folder, which is actually shared between the Studio and your host, you can see that there is an artifact that has been generated. So it has a long name because it contains every part that's needed to actually identify it. And that's it. So once you have this artifact, you can actually deploy it somewhere, like if you've done any development. In Ruby, you publish gems. In Python, you can use PyPy. In Java, you can use the Maven repositories. Here is the same. We have this thing called the depot, where you can push your artifacts. So this is an example of the UI. And it's also available on premise. So if you want to actually store the artifacts on premise, you can. Once you have created this artifact, you can export it to another format. And this is what's very nice with Habitat. So you create this Habitat for your application. And once you feel that it's good, that it's working fine, you can actually export this artifact to any infrastructure possible. So that means if you're currently using just bare metal or simple VMs, you can use the tarball export. Or if you want, you can export that to Helm chart so that you can actually deploy it to Kubernetes later, or just a Docker image or Cloud Foundry or whatever else. Or you can, if you want, not export it and just run it with the Habitat simple supervisor. So how exactly do you run the application? So the supervisor is here to supervise your service. So as I said earlier, it's like managing the life cycle of your application. So it's able to start it, to stop it, to update its configuration, so restart it or not, depending on what you want. So this sort of things. It can also manage the configuration of the service. So you create actually a configuration template that Habitat will populate with some variables that you provide it. And it can then generate the proper configuration file and restart the application if needed or not. Also, you can choose. And it can also update the service package, which is very nice if you want to have some kind of continuous deployment stuff. All these supervisors are actually working together, so you can peer them. They create an horizontal gossip ring, so no one is master, only peers inside this ring, and they can share information. So by sharing this information, they can actually, we can build new concepts upon that. So once a package is run, it's a service. And if you run several instances of your package, they will create a service group. So once they are as a group, they share some common stuff like the configuration first. So if you change the configuration for the service group, every application in every instance of the group will actually get this new configuration. They can also share some topology. So if you have to like deploy an application which have one master and several slaves, for example, you can specify that in Habitat, and it will happen all at runtime with still this peer-to-peer stuff, but one leader will be elected for the duration of the service group, and so for example, databases can start with the right configuration, because the configuration can take into account the fact that we are running as a leader or as a follower, and then you can start your MySQL server, for example, in the leader supervisor as a master and the other one as slaves. So this nice coordination is very, very, very cool. Once you have actually packaged and specify how you want to run your application, you can construct automation workflows. So this is like more for humans, for developers, for ops in the company. So the basic thing is continuous delivery. So out of the box, the on-premise depot does not do anything for you. It just stores stupidly the artifacts. But the SaaS application, so the hosted depot by Habitat, is actually running builder services. They are called like this. And what it does actually, it watches for your dependencies. And if, for example, you're using the GRA 8, which is depending on the OpenSSL package, if there is a vulnerability in the OpenSSL package, then there will be an update of this package. And the builder services are able to actually rebuild the entire universe depending on the OpenSSL stuff. So what it means is that you always get up-to-date artifacts on the depot. And then you can implement continuous deployments. So in the depot, there are channels. So this is like common vocabulary in the continuous deployment space. Channels, like, so you could have like UAT, pre-prod, prod, for example, and you can promote your artifacts from one channel, the default one which is unstable, and promote it to these channels to actually make the package move from one environment to the other. And this is possible because the supervisors are able to subscribe to these channels, so that works automatically. So now it's time for a little demonstration, if all goes well. Okay. Yeah, cool. You can see everything. Nice. So I'm going to show you the application mentioned in the slides. So it's a simple HTTP server, which shows a beautiful page. So it's a Spring Boot application, so we need to build it. Or maybe it's too small. Yeah. So we need to build it. Using Maven. Okay, so it will build. And then we'll get a jar. But I won't use it. I will just use the Spring Boot command and run it. So here's the application. Oh, it started. Okay, so it just said hello world and nice to see you all here. So these two parts are configurable. For the rest of the demo, it's useful to know. So I'm going to stop it, and I've already written the habitat package stuff because I don't have much time. So I'm going to enter a studio. So it was quite fast, but when you run it the first time, you have to download some dependencies from the public builder. So it takes a bit of time. And I'm going to just build the current package. So I'm not showing you some code now because I'm going to run a command that will take a long time, so I will do that afterwards. It was just meant to spare some time. So that's it, the package has been built. So once it's built, I can actually deploy it to the public depot. So this is the compression part. It takes a bit of time on my computer. Sorry. And that's it. So now we have this beautiful artifact here that's available at the bottom. So I'm going to source this results last build and file, which actually just populates some variables depending on the last build result, so such as the file name and stuff like that. And I'm going to upload the PKG. Okay, that's it. So here is just gonna upload it on the public builder. So the builder looks like this. The depot builder, it's interchangeable actually. It's just that the on-premise version is less feature complete than the SaaS one, but it's coming. So here I have access to my origin. So an origin is just a namespace in which we will have like some members and some keys to sign and verify your packages. You can launch some build jobs. So you can see here that I've run some stuff called my presentation. It's actually the presentation I've shown you before that's run on Habitat. The keys, so members have none because it's mine. You can choose it public, private, stuff like that. So now we should have a new package here. Oops, a bit long. Yay, it's here. Cool. And as you can see, it's in the unstable, or maybe it's too small, but it's in the unstable channel, and I'm going to promote it to stable so that it can be used by default by Habitat now. And now it's promoted, so that's cool. It works. And I'm going to export it to Docker. Oops. Okay, so I'm just telling Habitat to export to Docker the package I've mentioned afterwards, so it will fetch on the builder the package that's needed. So it's going to take a long time, and I'm going to show you afterwards what it looks like. So here's the application code. On the left, you can see the tree of the project. It's a simple Spring Boot application, so its configuration, the application properties, has three configurable variables. The first one is the big header, the second one is the subtext, and the final one is the port on which it will run. So in the Habitat folder, I have put the plan. So the plan is very similar to what I've shown you in the slides, with a bit more information, and this one actually works, not the other one. So we can see the same dependencies. PKG libdirs, we have also bindirs and some other stuff. It's actually, I've added it here, but it's not useful for Java applications, but for C or stuff that have to be linked at runtime is very useful, because Habitat can populate the required environment for you. So that's it for that. Sorry. We then have some configuration, so it's the same file name as we have seen before, except there we have some templated variables. So everything coming from the CFG namespace will be actually coming from your configuration that you define, which is in the next file, default.toml, that I will show you just afterwards. And PKG or sys or any other component namespaces of the configuration template variables are actually populated by Habitat at runtime. So you can actually have the real values coming from Habitat. So here I've put the PKG version. If the demo goes well, you'll see why. And the default.toml is actually just specifying that we have a variable named text that will contain some text, and a port that should be a numeric value. And finally, this is the run hook. So hooks are actually the same thing. You can like these are very real hooks. So when the supervisor runs, there is this life cycle for your application, for your service. And for each step of the life cycle, you can define a hook that will actually do or do not do anything, depending on what you need. And this is the run one, so it's the most important because it will actually run your service. And we just specify, so we run the Java with the jar that we have packaged inside the package. Okay, and we specify the configuration file. So here, pkg.svc path is populated by Habitat, depending on the current package that is run, so that we actually get the right application properties file. And that's it for the configuration. So I'm sorry, it's a bit fast because I have many things to show. So here you can see the output of the Docker build command, because Habitat did that for you. So I had to have Docker installed, of course, but that's it. Everything else is done for me. Okay, so now I'm going to actually run this image. So here on the right, I have prepared 3 terminals. Each one we are trying to launch, we are launching the package on a different local port, host port each time. Ooh, it works. Okay, so you can see, sorry, it takes a bit of time. Okay, so now we have 3 running applications, and you can now see that we have the actual version of the package that is running and the text that I've specified in the default.toml file. And now I'm going to apply some configuration. So here what I'm saying is that I'm going to apply configuration for the HTTP echo VDMS 2018 .default service group, which has been generated. This is the name generated because I've launched the Docker images just like this. So the service group takes the package name as the first part, and the second part is the name of the group that you specify. If you don't specify any group, it's named default. So what we are saying here is that we are going to inject some configuration for this group, and actually we'll override the default.toml that's packaged with the application. And the date stuff is because we need a version for this that should be incremented each time, so it's easier to use the current timestamp. So it's applied here. Sorry. Here you can see that setting. So my local on the top left, this is the local supervisor on the host, and every other one. I'm sorry, I've forgot to show you the command line. Actually, they all paired with the host supervisor, so they are all in the same ring now. And they also had this strategy set on rolling that I will show you just afterwards. And what's interesting here is that when I sent the command on the top, bottom left, sorry, this is the supervisor on the top left that accepted it, and it then just propagated everywhere, and every application restarted, and they should all show now the hello Voxxed Days Microservices. Yay. That works. Okay. Cool. So now I'm going to try to update the application and make it work. So for that, I have just prepared, so just modifying the version actually inside the package. I'm going to the studio, build the application with the new version. So it's building the right version now, 0.20.0. Almost there, bear with me, please. So it can take a bit long sometimes because this is usually the XZ compressing, and sometimes it's quite eager, but that's it. And I'm just gonna, oops, upload it. Yeah, I forgot the source. Okay. So I'm uploading a new version, which will appear just here, normally, if all goes well. And once it will appear, it will be the unstable channel, which means that it's not available by default for every supervisor asking for it. But I will promote it to stable, and we should see all the 3 instances of the package running that should upgrade one after the other, if everything goes well. So, almost done. that's done. Okay, so this is it. We have the new package. We can promote it to stable. Oh. Okay, so the latest table now should be 0.2.0. No, not yet. There is some problems with how the builder is coded for now. And sometimes the cache takes a bit long to refresh, and as long as it's not refreshed, the supervisor locally won't catch anything. That's it. It's okay. You can see on the right that it's 0.2 now, and hopefully we will start something moving quite soon. It can take at least up to 1 minute, so I hope it will fire sooner. So that's about it for the demonstration that I want to show you today. There is obviously much more to see because there are some more features that I couldn't cover and requires a more complex setup as we do have today. And as I'm late, I will just finish with the conclusion, and maybe we can see the thing working afterwards. So what we did with Habitat in my previous job, we actually deployed it in less than 1 week. And during that time, we integrated with Jenkins because this was our CI tool that we had at the moment. And we also have now centralized configuration, meaning that we have managed to decouple the configuration from our older repositories to a new one. And when we actually push to this repository, we have a small mechanism updating the configuration in the Habitat ring, and that makes the configuration versionable and versioned and continuously deployed too. And we are future-proof for infrastructure, as I've shown you, because we can deploy to Docker, to Kubernetes, to anything that we want. And how it could maybe help you. So the nice stuff about Habitat is it's an incremental deployment model, like you can use for very specific parts of your pipeline. You're not forced to use everything at once or either at all. You can just use it to package Docker, for example, and then deploy to Kubernetes the way you want. What's very nice is the common packaging and the configuration management that you can bring to an operation setting so that you can handle every application the same way. You can also package legacy applications easily with Habitat because it adapts to your application. So this is very nice if you want to lift and shift to cloud, for example, even for legacy applications. And the technical interface between developers and ops is actually Habitat if you choose to use it. And this can be very powerful for many workflows. And that's about it. Just going to check if we had some. Yay, it worked. Now it's 0.2. Great. And we didn't show live the one by one, but you have to trust me. Thank you very much.